But now you're here and we can hear you, so that's perfect. So let's start. Yeah, hello and welcome everybody also from my side to the session Solving Coding Challenges for Good. I'm Isabel and I work for CorrelAid as a community manager. So one of my main activities is actually the coordination of our local chapters. Local chapters are CorrelAid groups that operate on a local level, and they are spread all over Germany, France, and the Netherlands. And yeah, they pursue CorrelAid's mission on the local level with their projects. Just recently, we have many newly founded local chapters who are eager to start coding and work together as a team. But we also have some more established local chapters who are constantly looking for new challenges. So we thought, why shouldn't we use this regional diversity of our local chapters to be reflected in an internal project challenge? And with the regional statistical data in Germany that is available online, we had a first good prerequisite for such a challenge. So available online doesn't necessarily mean easily accessible. But luckily, we could build on the work of a Datenguide team and a Python package that was developed by Datenguide and a CorrelAid team. And this was how the idea of the internal CorrelAid X challenge was born. And Konrad will now tell you a little bit more about the Datenguide, the Python package, and yeah, the challenge itself. So yeah, Konrad, please share with us your knowledge.
Yes, thank you. So yes, so mostly I'm also part of CorrelAid, and I was part of the Datenguide Python package team, which was CorrelAid made. But maybe just I wanted to quickly share or show just the websites of the different. And so this is really what was already mentioned. This is like German regional statistics, so it's officially available data, but it's not. I mean, the website does not have a very modern feel if you look at it and you click through it, and I don't know, and it's a very inconvenient format. And then the next project that was already mentioned is this one here, which is Datenguide, and it's a bunch of data journalists essentially that thought like, okay, we need to make this open data more accessible for people to use it. And they made an API for this, and CorrelAid then worked together with them and built packages on top of it. And we initially started out building like an R package and built a Python package. And that was really what was used for the challenge. So we then thought like, okay, the Python package is in shape to really have people use it and try to actively sort through the data. And that's, yeah, well, first was a CorrelAid project really. So I was part of this project, really organizing it, and now it was the foundation for the challenge. So here's like a little bit of information about the package. So it's also on the CorrelAid GitHub. So it's really came out of the community. But now really the interesting part is really going back to our agenda here, and what we will hear in a second is what people did with it. And for me, as somebody who really made like an intermediate building block, that was very, very interesting, because it started out from really this very vague notion of, okay, some ministry is collecting data to like trying to mediate how people can easily get it, and then see how people are actually interested in using it. Because I think open data, in order to be successful, it also has to be attractive. People have to have the feeling, in one sense, okay, it's easy to get, but there also has to be something that might actually be usable, that might be presentable, and so on. And this is really what we did with the community. So it was very exciting to see what came out, what was used a lot, what was maybe not used a lot for further projects. And so in that sense, it was really a lot of fun looking at what people did, being part of the jury. And I think that's already all I really need to say to this. And then with this, I'm really excited to again see like what everybody did for the challenge, and also what they thought about it, really, because I actually being part of the jury, I saw all the results, but I haven't really spoken to every team itself. So I'm really excited to see what they did with this.
Yeah, thank you so much for this introduction. Yeah, you were quite lucky with being a jury member. You could see all the 5 project contributions that we had. And I'm also very excited now. So we have the 5 projects that, or teams that handed in their projects, presenting their projects for a couple of minutes. And then we have the possibility for a short Q&A session. So if you have questions on the project, please just put them in the chat and we try to answer them directly after each presentation. So we will start off with the winning project from our Berlin local chapter. So again, congratulations to the team around Cedric, Andreas, Sally, and Steffen. And I hand now over to Steffen, who will present this award-winning project. Hi, Steffen. So let's see if everything works with you technically. Can you say something? Are you still muted? Can you unmute yourself? Hi.
Hi.
Okay, I can hear you. I hope people in the audience can also hear you. And yes, we can hear. Okay, perfect. Now we are just waiting for Pia. I don't know where she is. Pia, maybe you can just request to share the audio and video again. There she is. Hi, Pia. Okay, I can also hear you.
Okay, great.
Okay, I hope this is okay for you that you start now. Okay, so then I'll be muted now and I turn off my video. The floor is yours.
Yeah, I just share my screen quickly. Okay. Okay. So, well, we're the local chapter of Munich, and we worked on this project in a team of 5 to 6, but well, now the 2 of us are presenting the project to you, and I'm Pia and this is Jay. So as you can see, our project was Charlie, the Datenguide chatbot. Maybe some of you have seen it on GitHub, and for others, we decided not to do a live presentation, but rather to tell you more about our motivation and our issues in development and how the chatbot works. And it will be online soon, so maybe that will just trigger you to have a look at it once it's online. So what were our thoughts behind developing a chatbot? Well, the Datenguide that was just talked about, we really liked the Datenguide, and it offers an easy access to the official statistics about Bavaria and about other states. But this is very useful for anyone who knows how to use R or Python. The problem is that not everyone knows how to code, and there might be a lot more people interested in having a direct access to the statistics. So actually Jay had the initial idea to build a chatbot that easily answers questions and renders visualizations about different topics in Bavaria, of course using the Datenguide API. Well, before we show you what the chatbot looks like, I just wanted to show you some of our first tries. So our first idea was to use Streamlit. Streamlit is a framework to build data apps in Python, and it's actually very useful for simple dashboards as it's easy to use. However, we quickly noticed that it's not suitable to represent conversations. But for anyone who it's constantly worked on, and I think it's great for easy applications. And we then decided to move to a combination of Flask and Spacey to build the chatbot. So Flask is using JavaScript, HTML, CSS, and Python for web applications. So it has JavaScript parts to write, which Streamlit didn't. And this is how our first try with Flask looked like. Well, and Spacey we used for the text processing part, for example, to match the user input with actual topics. Well, and Jay will tell you more about the chatbot, the actual chatbot.
Yes, thanks, Pia. Exactly. So after deciding on the technologies and fine-tuning the front end a little bit, we also set out to, of course, define the logic that the chatbot should implement. We call it a rule-based natural language processing because the dialogue of the bot follows a kind of structure, logical structure. So, for example, it first asks the user for the favorite city in Bavaria and a topic of interest. Then the input of the user will be passed by Spacey, the language text processing library, to extract the keywords, and those will be then matched through the Datenguide API to this official statistics database. And in the end, so the bot can visualize the statistics that was queried by the user, so to say. Of course, the user can also download the raw data in format of a CSV file. Of course, this flow is not exactly linear because the interaction between the user and the bot can go back and forth and may even diverge in terms of different answers and questions. And diagram on the right-hand side is supposed to show you the, so to say, the dialogue flow, or roughly the complexity of the chatbot. If you go to the next slide, please. Yes, so this is a screenshot of the, so to say, end product of the chatbot. As you see on the right-hand side, you have the conversation panel, where the user can interact with the bot, and on the left-hand side, certain kind of data visualization can be rendered. As Pia already mentioned, we are currently working on still working on the deployment of the web application. But in the meantime, of course, you can visit us at the GitHub repository, and I think all kinds of contributions are welcome. So go to the next slide, please. Yes. And in the next iteration, what we would really like to do is some kind of a question answering system. Because, or in other words, we want to make the bot, so to say, more intelligent. So the idea is to, so ideally, the chatbot can, first of all, so understand the question in natural language, and then automatically figure out the answer to the question based on a certain types of data, or in this case, a database or a fact table. There are a lot of, this is actually a quite active research area, and a lot of example of frameworks have been open source. So this here I showed one example from Google, where they open sourced this task model or a framework where the question can be encoded and trained together with the tabular data, and in the end outputs the answer to a certain type of question. Yeah, so this is the outlook, and to go to the last slide. Last but not least, so Pia already mentioned, so we are of course not alone in this project, and also thanks goes to Daniel, Michael, and Floria. Yeah, I think that's it. We are happy to take questions if there are any.
Yeah.
Thank you.
Okay, yeah, does anyone have any question about the chatbot?
Yeah, please put your questions in the chat. So let's see. Maybe people also need to process the information first. So of course you can also like ask a question later for this team.
Sure.
Okay. All right. Doesn't seem that there is a question. So my question is now, is Steffen back here in the session? Because maybe we then continue with Bremen, with Long. So
Right.
I say thank you to both of you. What a cool project. So yeah, just leave this area, please. And see you later. Thank you so much. Bye.
Bye.
Okay, so then I bring you up, Long.
All right.
Thank you. Okay, I can hear you, so that seems to work, yeah.
Right.
Thank you for, we just do a different order of presentation, that's all right. So yeah, feel free, the floor is yours. I'm looking forward to see your project.
Yeah, thank you. So my name is Long. I'm actually part of both the teams from Bremen and Hamburg, but I'm now presenting the challenge results from Bremen. So yeah, we did an interactive dashboard about commuting in Germany, and it's online here thanks to CorrelAid. Yeah, looks like this. We have a table, also maps where you can, I can show you that later because I have to move on with the presentation, but yeah, it's interactive and it's quite informative, I hope. So yeah, the presentation is about the what, the why, and the how, why we did, or the how we did this dashboard, and first of all, the what. So the dashboard is about commuter statistics. But,
sorry to interrupt. Sorry, did you already share your screen? Because we cannot see that. Yeah.
Oh yeah.
So please do. Don't worry. But would be nice to follow your. No, you're not dumb. No, but would be nice to follow the presentation. Are you able to? Yeah, perfect. Yeah. Okay, now we can see it. Okay. Perfect. Thank you.
Yeah. Yep. Sorry. I'll begin again. Yes. So the dashboard is online on Link. It's hosted by CorrelAid, and it's an interactive dashboard about commuting. I'll talk about the what, the why, and the how of building this dashboard. And yes, it looks like this. We have like interactive tables and also map. And yes, so first of all, what is this dashboard about? So the topic is commuter statistics. Yeah, so it is actually not about commuting, but rather about the place where people work and live. So the definition of the statistics is that those people who are commuters are those who live and work in different municipalities. So yeah, maybe a convenient way to capture commuting, but not entirely an accurate one. So for example, here we have Berlin, and in the year 2019, this is incoming. So what it means is that the number of people who work in Berlin but live elsewhere in 2019 were 9.14% of the total population of Berlin. So yeah, that's what this dashboard is about. So why did we do it? Yeah, so why commuter statistics? Because all the people in our team, we are social science students. We're interested in identifying regionally important industry or business locations, and also on the basis of that, comparing the relative importance of districts and states in Germany for work, and especially for us in Bremen. Yeah, we have this so-called Speckgürtel, or the suburbs that are outside Bremen, so in the state of Niedersachsen or Lower Saxony, I think. Yeah, so those people who live outside of Bremen but work and earn their money in Bremen, and then because they live outside Bremen, they pay their taxes outside Bremen. So that's especially interesting for us to see. And yep, that's the substantial part why we did this. But why a dashboard? So yeah, why not a chatbot, or why not some fully fledged online app, but a dashboard? Because yeah, we're all students, and the challenge took place in August and September. As you can see here, our schedule was not really, well, didn't allow us much time. So a dashboard is an easy way to visualize things and also to communicate things effectively, also time efficiently. So time was the most important factor for us. So yeah, just that's why we decided to do a dashboard. So how do we do it? First, we queried the data from, or with the help of DatenGuide, which provides an API via Python to DatenGuide, which is in turn a ginormous collection of regional statistics at different levels. So Pia and Gio also talked about DatenGuide and DatenGuide a bit more in detail earlier on, so I won't go much into that. Yep, querying data with DatenGuide is straightforward, so thanks Konrad and co. Yeah, because it's just pandas syntax, and well, it was also fun learning pandas and Python for this challenge. But yeah, caveat is that querying data for a lot of regions and indicators can take a lot of time. Also, another caveat, which is actually not the fault of DatenGuide or DatenGuide, but I think it's the fault of history, is that some region can just change their IDs, their official IDs at some point in time, and even without any apparent reason. So that we had to look into and fixed manually. Yep, and after we had collected the data, we could create a dashboard using R, because yeah, most of us, or actually all of us, are more better in R than in Python. So we opted to use Flex dashboard instead of, for example, Shiny dashboard, just because it would save us time. Still, we couldn't really totally avoid Shiny, because we wanted the dashboard to be interactive. So we used runtime Shiny pre-rendered, and also here instead of runtime Shiny, because pre-rendered saved even more time. Yep, and consistent with the motivation, we used Reactable and HiCharter for the tables and the plots in the app, because yeah, so they were nicely out of the box, and we didn't have to spend a lot of effort to make those look decent or even nice. Yep. So what we learned from making this dashboard was, yeah, I think we learned a lot about commuting patterns in Germany. You can have a look yourself at the app, and maybe you can find out some patterns for yourself. And yeah, just yep, so a lot of things, a lot of interesting information in there. But what's missing right now is that data from 2020 is not available yet, and because of the situation with Corona and remote working, might be even more interesting this year to look at the commuting patterns in Germany. Yeah, on the technical side, most of us were newcomers to Python, and after that, could all say Python's cool, pandas is cool, and especially DatenGuide is also super cool. And last but not least, as they say, open data is important, but also accessibility is very important. So again, thanks DatenGuide for and DatenGuide also for the package and the API. Yep, if you're interested, you can check out yourself the dashboard at this link, and the source code is also live on GitHub. Yeah, that was it. Thank you for listening. I think I can stop sharing screen now.
Thank you, Long, although this was such a funny picture in the end.
Oh.
Yeah, thanks a lot for the insight. So yeah, we need to wait a little bit for the questions, because people also need to type. But we already put the link to your project in the chat, so that people can now also simultaneously check it out. So that's really cool. And Henry already mentioned or put in a comment, he said that he discovered that Wolfsburg is leading an inn, and he always had the impression that quite many people commute there, even from, and he thanks you for the insight. So cool. And Konrad says, actually, official statistic regions have a hierarchy in the IDS. So if there's a regional change on a high level, let's say state level, then all sub-regions, let's say counties, will also get a new official ID with no apparent change on their level.
Oh yeah, of course. Yeah, that also, and especially for our case, I think it was that some regions were merged together or split, but then some changes, we couldn't find anything on the internet, but maybe we just didn't look enough.
Okay. Well, all right. So I don't see more questions coming, and I hope I gave people enough time to type. But you can, I mean, even if Long is leaving the section now, he can still answer you in the chat. So as Pia and G already did that before. So my question is, thank you, Long. Thanks a lot. Is Benjamin here for the Rhein-Main chapter? So if you are here, please request to share audio and video. So you are here. So let's see if we can hear you.
Hi, can you hear me?
Yeah, perfectly well. Okay, then yeah.
I'm gonna share my screen.
Perfect, thank you.
A second. Oh, yeah. Yeah, it worked, right?
Yes, works.
Can you see the presentation?
Yes, we can see the presentation.
All right. So, welcome to our presentation. I'm going to present on behalf of the CorrelAid Hamburg chapter, our project on child well-being in Germany. And a little side note, we are a quite young chapter, just formed a few months ago, and this is our very first project we worked on together. Yeah, so there are currently 10.6 million children under the age of 14 living in Germany, and in the latest UN in a Center report of this year, 2020, Germany ranks 14th on the global ranking on child well-being, and in some subcategories like skills that children acquire, it ranks even lower. So we asked ourselves, okay, this is a global ranking, but how does it look in the most proximate areas? Like, where do I retrieve, for example, information about child well-being in my federal state or the city, or even the zip code area? Wouldn't it be nice if there was one portal to access all these information combined? So first we asked ourselves, what exactly does, what determines child well-being? And the UN define child well-being as the combination of the mental well-being, the skills, and the physical health. And these factors are a function of a lot of other bigger factors like activities, relationships, or resources like networks, household, income, school, and so on. So this is quite a lot to take in and to process and to put into consideration. So for our project, we limited the number of factors to about 20, and just to name a few, we looked at the percentage of child population in the different areas, how many childcare facilities there are, how many children are in daycare, how many of them are affected by divorce, how many school leavers actually leave with the highest school education certificate, and the share of sports and recreation areas, for example, and many more. So we used data by the Datenguide API and from the Bundeskriminalamt. And then we built an app that looks like this. It's a browser app and it's a Dash app built on Python. And I will give you a quick look on the live app. So this is the app. And here on the side, you can choose a factor or a label, for example, child population. And then you see on the federal state level that in the West, there are more children than in the federal states in the East, except for Berlin. Or, for example, another factor is the share of sports and leisure and recreational areas, for example, football fields and playgrounds. And as you can see, there's quite a gap between the cities, the big cities in the north, and the bigger federal states. Yeah, so you can also see the development over the years if there's data available. So just like this, yeah. Well, if you have the map and you want to, you then can go and look deeper into the data and see if the gaps or the differences between the different federal states are big enough. You can take a closer look. Like here, for example, we looked at the sports and recreation area and the child population. And as you can see, there are more recreational areas in Berlin than there are in different other federal states, but also more than in Bremen and Hamburg, for example. And the idea behind this is to inform more questions that can be asked and put forward or to community leaders and politicians, for example. And what we learned during this project is that building an app is a quite intuitive access to information for lay people who are not used to statistics and processing data. You instantly have a geographical orientation, so you can position yourself in your city or your zip code area, and you have the instant comparison of regions. In the future, we might also add some data that is, for example, specific to mental health, and provide online hosting for the app, and maybe create also a mobile version. Thank you very much. Are there any questions so far?
Thank you, Drenizë, for the presentation. Yes, there was one comment actually. Can you also see the chat? If not,
not yet. Just a second.
Okay, it's also jumping up and down.
Oh, yeah.
There's a comment from Cedric, who says, with regard to the differences in playgrounds, etc., maybe consider estimating the proportion based on urban area per federal state and not the absolute area. Just as a comment, or I don't know if you thought about that as well.
Yeah, it was the data came like that. So it was a proportion already. We didn't compute it ourselves. So we had to work with the data that we had. Okay, all right. And then another question was, what Python packages did you use to build the app? We use the basic packages like NumPy, Matplotlib, and so forth. We use GeoPandas to create the map, and and we build it in Dash.
Okay, all right, cool. Well, any more questions from the audience? If not,
it's really easy to build it yourself. We did I also left the link in the presentation to the GitHub repository, and if you just follow the instructions down below, it's like 4 steps or so. You can easily build it. I built it just with the command line in Windows, so you don't have to install any fancy IDE. Just Google the command to import the YAML environment to have all the requirements, and then it should work. And it's quite fun to just have it there and explore the data visually.
Cool. Maybe you can put the link to your GitHub in the chat as well. So
yes, just a second. That's a good idea.
Okay. Yeah. Also the other teams if you want to, and people can take a further look. Okay, so I wanted to ask who will now present, because I know there was some hiccups, but it's you join us now, so it's going to be you, right?
I think so, unless Cedric, he's in the session, but I think he was just having his dinner, so I will just.
Oh yeah.
You can leave again, Cedric. You don't have to stay. Yeah, Cedric will talk tomorrow about the more technical aspects of building this application. Yeah, and I got a short briefing from Steffen. Apparently his mic is really broken.
Working. Okay.
So we also tested it via Slack and other applications, but it does not work. So I got some notes.
Nice.
And but I think it will fit quite well because we don't have so much time left. And so
exactly.
I will just share my screen and
I mute myself again. Thank you for hopping in.
Yeah, I mean, I had a look at the application when I was deploying it on our servers. So yeah, this is the application. And first, a bit about the infrastructure, about the motivation behind this project. So Steffen told me that yeah, it was with the COVID and everything. Of course, we have a lot more pop-up bike lanes in Berlin. So during COVID, a lot more Berliners were taking their bikes to go to work. And so the Senate decided to put up some like ad hoc bike lanes. And that's how they got the idea to choose this topic for this challenge. And yeah, so I think the other thing is how, and I will talk about that later. But yeah, let's just first have a look. So it's the app is a scrolly-telling app. So there's there's different slides for the app, and this is the landing page, so to say. It's already looks really nice. I think when I saw it for the first time, I was like, oh, this looks really nice. But yeah, maps are of course always good. So if you go down, you get a really nice description, and that's also, if we can maybe skim through that. So there's some stuff about CO2 and climate change, and yeah, so it outlines the motivation of this project quite nicely. So you can also read that at this URL. So if it's slow, then this is maybe not because of the app, because it's on our server and our server is quite small. So first thing I want to show you, or I was told to show you, is that here in this panel you can compare with different cities, and yeah, you can see how many injuries, accidents with injuries there are. And so it works really nicely. You have all those hoverings, and I was told to show that there's a difference if we go to per 10,000 cars. What's happening? It's probably like presentation effect now, or it's my computer because I have 5 streams on at the same time. So let me reload that. Yeah, so it's reloading. Now you're all on this website, right? That's not good. Okay, let's go to this. Oh, now it's reloaded. Okay. So, no, this is not working right now. Okay, let's just go on. You can check this out later. So you can also see the participants who are involved in accidents with injuries, and you can also add some more. Of course, this is also not working right now because you're all on the website. Yeah, so this is yeah, it's my fault because I did not make it very scalable. Yeah, but we can still browse around here a bit if we don't use the interactive features. So I was told to go to Straße des 17. Juni, which is here. So this is good for me because I just recently moved to Berlin in in March, so I can practice my Berlin skills. And so here you have this big street, and what Steffen said, that it's kind of remarkable that there are not so many accidents because it's quite a busy street. There's a lot of traffic, but he said that he also takes the street with his bike, and what's really good about it is that it has like a really consistent biking infrastructure. So you have all the way here, you have on sidewalk, on sidewalk, on sidewalk. Now it reloaded. So let's go back to the map. Now it might take a while. Yeah, so I think what most of us know from experience is when we take our bike in the city that it's really dangerous if there's a lot of changes, right? If it's like you're on the bike, you're on the sidewalk at one point, and then you're on the street again, and then you're on the sidewalk, and then there's some different thing, and so that's when it gets really dangerous. And so this is something that you can see in this map that I just showed you. You can browse around and see the individual accidents, also by whether it's night or day. And yeah, let's see whether this loads or not. Yeah, again, it's not the app's fault. It's my fault because I did the deployment. Yeah, and the other place to check out that I was told to check out by Steffen is the Kastanienallee. Yeah, now we can have a look. So yeah, again, the biking infrastructure is quite consistent. And then I was told to go to Kastanienallee, which I think is here. If I compare with my Google Maps on the other side, Alte Schönhauser Allee. Oh gosh. If someone wants to jump in and help me find Kastanienallee. Rosa-Luxemburg-Straße. I think I'm to Spandauer Vorstadt. Ebersweiler Straße.
More to the north. Just try.
To the north?
Yeah, but I can barely see that.
Are you sure? Greifswalder. Yeah, here. That's it.
Okay, cool.
The street. Thank you. And yeah, so apparently there are quite more accidents, especially given that it's not such a big street, right? It's not a main street like those streets here. But what's the case here is that you have what I just described, right? It's like sometimes it's I think advisory bike lane, and then it switches over to the sidewalk, and here you have another switch. And I think I walked there at some point, and there was a lot of parked cars. So it's really dangerous in comparison to how many cars are driving there, probably. And yeah, you also can see whether the accident was in daylight or twilight or darkness. And you'll see that here it's all in the day. So it's not a problem with illumination or something like that. Yeah. Maybe we can also go back to the other thing now. Maybe it works now. Yes. So let's see what we have. So we have per 10,000 inhabitants, we have 67 accidents with injuries and 62. So that's pretty close. And then if we go to by 10,000 cars, now we see it, right? So this is quite similar. And then if we go here, we can see like Munich has way lower statistics by number of cases by the number of cars than Berlin. So yeah, and maybe a bit on the how. You can also check this out on the GitHub. I think it's called what is it called? X Berlin.
Yeah, the link is also in the chat.
Yeah.
And Cedric is now with you, so he can also answer some questions.
Okay, very good. Yeah.
Can also show some more stuff that he runs locally. Okay, Cedric, so you're now in the session.
No, we can hear you.
Yeah. Can you say something?
We can hear you typing.
But maybe he can't hear us. Oh, okay, well. But yeah, you told him that we can hear him, right? So that's actually more important.
Yeah.
All
so
right.
You can, I don't know. He can't hear us? I don't know.
Doesn't seem like it.
Yeah, I will just keep talking.
Yeah.
Yeah, on the how, yeah, it's built in Shiny with some packages which are quite important for that. You can, I think the main one is called Pages, something Pages. The main package, maybe Cedric can confirm that in the chat. That gives you the ability to have those nice scrolly things here. And then this package for the this is full page, that's the one. Then I don't know what the package is for those graphs. Probably like a JavaScript wrapper library thing. Yeah, and it's also packaged in Golem, which is a package that allows you to package your Shiny apps in an R package. It sounds like a bit weird, but it really makes a lot of sense and makes it also easier to deploy things to servers. And Cedric will talk about that tomorrow in his talk. So make sure to check that out if you're interested in more about that. Yeah. And so there was the why, the how, and what else, Isabel?
Oh, I mean, that's already pretty good. Thank you.
Okay.
Yeah, because also I'm just looking at the time, and it's
so very good.
Very good timing, actually. And yeah, and I think unfortunately Cedric can't hear us. I can hear him.
He can hear us.
Okay.
I also muted Cedric. That
Okay.
could be the reason.
Yeah. So he answered the question how the charts were made.
Charts.
Yeah, exactly. Right. And yeah, Steffen says thank you, free without any preparation.
Yeah.
So,
I see that now. Yeah.
So now we know why it's called hop in, right? Because you just hop in and do the whole presentation.
Yeah. That's what I do.
It's actually also nice because somebody mentioned in the chat that this could be very interesting for the ADFC. And this shows how like this kind of internal project turns out to maybe become like a real data for good project. And also Liam, who told us a little bit before about the data dialogue. So it all comes together because they are already in touch with the ADFC, and fingers crossed that they will attend the data dialogue, and then this might become a project. So started off as an internal project, but also if there's any more NPOs sitting in the audience and you think some of this data was interesting for you, reach out to us because yeah, we would be happy to share it with you. Yeah, so these were the contributions for the challenge. I think it's pretty amazing what came out of it. Yeah, congratulations again to the Berlin team, and you can hear more about this tomorrow. And yeah, so this is actually like already the end of like the first formal part of the CorrelCon.